All right, if you will, just bear with me on this one. Hopefully all this makes sense. I thought I would just make a little video and show you this diagram versus trying to type something out. And anyways, listening to what your problem is or what your symptoms are, you know, you're getting, I hear the solenoid clicking. So we know it's not a key switch problem or a micro switch, pedal switch problem. That solenoid wouldn't be clicking if either of those two things were bad. But anyways, normally the way I test these systems, I use a test light. That's why I was asking if you had one. It makes it a little bit easier to see what's happening and understand what's happening. But anyways, all we're going to be doing now on this test is just tracing the flow of current through the system and making sure it's going where it needs to go and there's nothing stopping it from doing that. First thing you need to do is test to make sure power is flowing through your solenoid, the two big posts here. Anyways, just hook your negative lead to your B negative up here on your controller. Since your batteries are in the very back of the cart, it does the same thing as hooking it straight to the battery pack. But anyways, you want to test the battery side and make sure you're getting 12 or 48 volts to the solenoid from the battery pack. And then you want to test it after the solenoid's engaged over here to make sure current's flowing through the solenoid after you give it throttle. You do have this resistor right here probably. I didn't see your video too good, but anyways, this is going to carry some voltage and it'll probably be a little bit different when you're not pressing the pedal down. That's why I like to use the test light for this, because if you probe it here, you're going to get a little bit of power through the resistor and the light's going to be kind of dim. But when you give it throttle, the light brightens up and lets you know power is flowing through. So anyways, when you go to do your test, well, like I said, you'll probably see less voltage on this side when it's open. And then when you give it throttle, it'll go back up to the same voltage that you saw on this side here. But anyways, we're going to test the two big poles, make sure power is flowing through the solenoid. If they're flowing through the solenoid, through the big poles, then we're going to test the output of the controller, and then we're going to test the forward and reverse module and the motor. All right. So to test the output of the controller, you're going to hold your positive lead on the B positive side over here, coming from the battery, and then you're going to put your negative lead on M negative here on the controller. All right, and then you're going to slowly give it throttle, all the way wide open throttle. And what you should see is a gradual increase in voltage as you give it throttle. That means the controller is outputting power back to the motor. If you don't see this output, the controller's bad, or something's wrong with your throttle circuit over here that's not giving the controller a signal telling it to increase the power to output to the motor. Anyways, I know this is an all-track schematic, but everything should be identical as far as the main connections. I just like these all-track schematics because you can see everything really well and it works good for making videos like this. But as long as you have a newer style controller with 3 outputs, which the Navita should just have the three connections on it, all this should work the same. So anyways, we tested here, like I said, with positive here, negative here, and we've got power output. So then we're going to follow that wire up to the F&R module over here, and we're going to test where it goes into the board right here on this post here. All right, so you're going to do the same thing. Push the throttle slowly all the way to full throttle, and you're going to look for a voltage increase. If you have a voltage increase, you're going to move up to the output on the cam here. Now, before we keep going, I'm just going to kind of give you a really quick how-to right here on how this board switches the motor to make it go forward and reverse. To make a series motor run forward and reverse, all you're doing is switching the path the current takes going through the field windings or the series on the motor. All right, so in my scenario here, I've just drew it in one direction. It's coming out of S1 on the cam and going into S1 on the motor. It's going out of S2 from the motor back into the cam, and then it ultimately will come out of A2 and keep making its way through the diagram. If we want to go the opposite direction, when we flip this cam the opposite direction, power is going to come in M2. Instead of coming out S1, it's going to come out of S2 this time. It's going to go through S2, out S1, into S1, and then out A2, and so forth. All right, so that's how this circuit works. All you're doing is flipping the direction current flows through the field windings on your motor. All right, so anyways, we've tested here, we had power here, we've tested here, the output on the cam, and we've got power flowing through the bus bar into the lug and out to the wire. That's one main area where I see where it doesn't make good connection and you don't get current flowing through that area. All right, so then we're going to trace this wire back to S1. All right, we're going to test it on the motor, on the plug, on the lug here on the motor, to make sure that current's flowing all the way back through the wire. All right, then we're going to test it on S2 coming out of the motor to make sure current's going through the windings, the field windings in the motor. All right, so if you have power going in but you don't have power going out, you know that the field windings are messed up somewhere, and that's going to be your issue. So anyways, let's say we have power on both of them. Then we're going to follow the wire back up to the FNR module. All right, we're going to test this S2 lug on the cam, just again confirming that the wire's flowing current. We get current there, then we're going to check here at this A2 lug that comes out of the side of the board and make sure we have power coming out there too. Same procedure, give it full throttle, looking for a voltage increase. All right, then if you're getting power through all of this, next you're going to follow that wire back to the motor again, but this time you're going to test at the A2 post, or wherever this wire is connected. It might be A2, it should be at A2, but just depends on how you wired it. It might not be. But anyways, you're going to check it here, and then you're going to make sure it comes out the other A post, A1, and again, same test. Push the gas, watch the power increase, the voltage increase. All right, this is probably going to be the second most, the second weakest link in this system are the brushes in the motor on the armature. This is a lot of times where I see this issue occurring. So what happens is you get it under a lot of load, the cart, and you can't move good because you got a lot of weight, but it's still pumping all that power into it. And what it does, it overheats the brushes and the wires where they're like soldered into the brush, and it just melts them off. And then current doesn't flow through the armature, and that's where you get a no-run scenario. So anyways, you're going to test that pole, A2, then you're going to test the A1 pole and make sure it's coming out. And then if you're not getting anything out of A1, then you know that your brushes have been melted off. But anyways, before you jump to the conclusion that the brushes are melted, I would switch directions on your FNR and do the same test again to make sure current's flowing through all these connections properly. So anyways, hope this helps. Let me know if it works for you. Let me know if it makes sense. And if you get power at all these places and it's flowing through everything properly, then we'll move on to checking the throttle here to make sure the throttle, that if it's flowing through all this, it should be working. But if it's not, it's either going to be in one of these connections where you're not getting power, or if you're not getting anything at all coming out of the controller, then we'll check on the throttle here to make sure the throttle is sending the proper signal to the controller to tell it to do an output back to the motor and to the forward and reverse. Anyways, let me know what you find out.